Hi there, and welcome to your lesson on fluid systems. So today we're going to put together everything that we've talked about with regards to pneumatic and hydraulic static systems, and we're going to put them together in a together as a system that will achieve some desirable outcome. And we spoke previously about the hydraulic press, so the press that uses hydraulics to lift a vehicle or a heavy object using Pascal's principle to transmit and control the forces in the fluid. So we're using the fluid within a contained system to do some work. So today we're going to look at a complex system, in particular a hoist system, to find out how all of the topics that we've discussed can work together to perform a task. Now, the first thing you need to understand is what a fluid system is. And a fluid system just simply is an arrangement of components, or parts used to transmit and control forces in a fluid. And many of these systems are in operation within vehicles. There's medical applications, there are aeronautical space engineering applications like the Canadarm. And we're going to take a look at how we can put it all together. What's really important, first of all, is we need some initial energy input. And for the hydraulic press, the initial energy input is from an electric motor. So as we go along, it's important for you to follow kind of the flow of energy and forces. And we're going to start with the electric motor. And on the output side of the system, that's our desired transformation and energy transformation. And in this instance, we want to lift a heavy object. There's a special name for the final output device, because we're going to transmit electric energy into fluid pressure throughout the system. But at the end of the system, we want to change that fluid pressure and force into some useful form of energy. And the term we give to the device at the end of the system that transforms fluid forces into a mechanical force, like a lifter or a pusher, is called an actuator. And this is a generalized term. There are lots of different types of actuators, but the actuator happens at the end of a fluid system and transforms that fluid pressure and force into some other type of energy. Now the question is, what other types of actuators are there? And we're going to get you to know just a couple of those. Your objective today really is to be able to describe in detail how the system works. What are the components of a fluid system? The generalized components, that's what you need to know. You need to be able to tell the story of this particular fluid system and how we use pneumatics and hydraulics to achieve some output. So going back to the actuators, you can turn that pressure into electrical energy again in the form of a solenoid. You can have some manual pushing. You can have a pressure actuator. You can have a spring acting actuator. Anything that can transform pressure back into a mechanical energy. So there's our beginning and our end. Start with an electric motor. Want to lift the car with as little energy input as possible. Let's follow the pathway of how it all works. So you've seen previously how pressure is distributed in the liquid to all parts of the liquid and all parts of the walls of the container of the liquid, and that is Pascal's principle. Our objective today is to understand how that pressure is controlled and used, in particular for this example. All the components, the generalized components that we'll learn about, link together, and they form like a circuit, like an electric circuit, except this is a pneumatic and hydraulic circuit, where both air, pneumatics, and liquids, hydraulics, work together to give us some mechanical advantage. If we were just to use a motor to lift the car up, we'd need a pretty hefty motor, and so we're interested in using as little input energy as possible to do a lot of work. We want a high efficiency here. So let's get to it. The first thing we're going to do, we're going to start with recognizing that the blue system here, anything in blue, is air, and then anything in the, I don't even know what color you call that, rose? Is it rose? Do I have a rose color? Oh, maybe this one is oil or hydraulics. So there's a separation of the two. If we were to use air to lift the car, because air is compressible, we'd have to use a lot more air to lift that car. So we want actually the fluid to do the heavy lifting. So here we go. Let's start. Well, we want to start with air. Why do we want to start with air? Let's find out. Okay, so the first part of this whole system starts with, let's use pink, starts with intake of air. So air is going to come in. We've got this air compressor here, which is going to compress the air so that it has a pressure in it. And that compressed air is stored in this tank. And containers that are under pressure are always indicated by this boxy symbol. And we'll take a look at the symbols in a little bit. That means that there's compressed fluid of some kind in there. Now, should there be some kind of error, we want a way for that compressed air to escape so it doesn't explode if there's some weakness, or if there's some sensor that allows too much compressed air to be stored in the tank. For safety reasons, we want an emergency escape, and here's our pressure relief valve. So that's really important. So we got air coming in, it's getting compressed in the compressor and stored in the tank, and we have a pressure relief valve. And the word valve is really important for you to know, and you will be responsible for being able to understand different types of valves. And the first valve that we'll take a look at is this guy right here. You twist this thing, the plunger moves down, and you can see that it can block off, as it sits in here, it can block off air from entering the rest of the system. This is going to be closed when we want to pressurize the tank, and when we want to move that pressurized air out, when we want it to move out, we're going to open it. Now, valves are extremely important parts of pneumatic systems. They control fluid systems, and you can see that this is a two-way valve. It's an on and off two-way valve. And that means there are two possible positions for the valve to have, on or off. The other thing to notice about valves is they all have ports. This particular valve has two ports. That is, it has one way in and one way out. So there are two openings within the valve chamber. So we can say that this valve has two ports. Two ports. Okay, so the compressed air then is allowed to flow through the open valve into this container here, and this is another filter, and it allows the collection of whatever this filter did not catch. It allows the collection of particles that may damage the components. We definitely don't want bits of grit down here, as they'll scour and ruin the insides of this valve. So we want extremely clean air entering the next section, as we have more moving parts, more mechanically moving parts in there. So we got this filter right here, and we've got a way to clean the filter. And here we can see that there is a term you need to know, and that's a transmission line. So any conduit that allows the flow of a fluid is called a transmission line. So that's a transmission line. There's a transmission line. There's a transmission line right there from one part to another. And you can see the value of these fluid systems is that these transmission lines can be flexible. And if you've ever worked with copper piping, relatively easy to cut and solder together into different configurations. Okay, here we have the next part here. And this guy that I'm outlining in blue is another valve. This is a three-way valve. And that means a couple of things. Number one, you can see that it has 3 ports connecting to it, 3 conduits connecting to it. So that's why it's called a three-way valve. And as you adjust the valve, when you push this plunger over, you can see that this sheet here is going to move here, and this sheet is going to move here. And you can see that air can move this way out through the muffler in that position. I'm going to erase this right there. So this valve controls the movement of fluid. When the valve is changed to a different position, described by this position here, you can see that air through this transmission line is not able to pass up into this transmission line, and in fact air can only move between these 2 ports here. So this valve, it controls the flow of the fluids. We can turn it into 2 different positions, one position and the second position when these valve checks here are moved into this position. So 2 different positions, 3 ports, and you'll find that valves are often described using that language. How many ports and how many different positions can we have? What is the purpose of this valve? Well, it says right here that it controls the direction of airflow into and out of the first pressure cylinder. The first pressure cylinder is this guy right here. Here we have a muffler that allows air to escape, because we not only want to lift the car, but we want to be able to lower the car as well. And when this fluid pushes down, it's going to push up on this gas, and we don't want this gas to move back up into this system. We want to keep the air flowing in this direction. So we turn that valve so that it is in a position that looks like this. And when the car is being lowered and the gas is being pushed this way, the gas can escape into the muffler, allowing us to move the car down. So that's the purpose of a valve, controlling direction and quantity of gas flow. Okay, so let's just pause for just a minute. We've learned about the word actuator. We've learned about valves. Another term you need to know. You need to be able to identify how many ports a valve has, and also how many different positions the valve can possibly be in. If we look at this position, this valve has 2 ports, 2 possible positions, open and closed. If we take a look at this valve, it's got 3 ports and 2 possible positions as well. I guess you could say 3 positions. We can close off the entire system if we wanted to, so that air doesn't flow either way. So this is a 3 position 3-port valve. Okay. Well, let's keep telling the story though. We have pressurized air that is moving through this valve, through the transmission line, through the filter, down this transmission line, through this valve, and is applying a force that is a function of the area using Pascal's law down here. And here is the interface. The first pressure cylinder is the interface between the pneumatic system and the hydraulic system. And we're using the pneumatic gas to create a force or pressure. And we don't need a lot of force or pressure. That's why we're using the compressed gas, because we know through Pascal's principle where pressure on the small surface area is equal to the pressure on the large surface area, it's going to allow us to lift this. Now you may be wondering, and I have a problem with this diagram because of this, but this lift, you can see the surface area, the area is actually smaller than this guy here. What this diagram is not telling us is there is another 1 or 3 other lifts going on as well. So the total area can be multiplied by 4 and will be greater than the area here. So that's one issue I have with this diagram. So just be aware of that. Don't be confused. As we have a force being pushed down in the hydraulics, the fluid, which is not as compressible as the gas, transmits that force to all parts of the fluid and enables us to lift the car. The actuator is this mechanical plunger. Remember, the actuator transmits the fluid force into an actual force. Mechanical force of whatever we want to have happen. Okay, so when we want to lower the car, let's get rid of this stuff. Simplify the diagram. When we want to lower the car, we don't want to lift it anymore. What we have to do is allow the mass, the mg, which is the weight, of course, the force due to gravity, to exceed the force that's pushing down here. So how do we release the force that the compressed gas is applying to the fluid? Well, we need to use this 3-port or 3-way valve. We want to allow that gas to escape. So we want this compressed gas to exit the system. So we're going to turn this valve so that this route is blocked and this route is open. And we can do that in a controlled way using this valve. So we can close this port a little bit, we can close it a lot, we can open it all the way, we can control the escape of that compressed gas. And we can lower the car. So these joists have both a pneumatic and a hydraulic system that work all together to perform a task. Initial energy in by way of the electric motor, and the actuator is the manifestation or the mechanical work that we want to have happen through the system. Okay, so there you go. There is a fluid system using Pascal's principle, introducing the idea of components in a fluid system, transmission lines, valves that can be described, actuators, initial energy input, and to make it all a little more interesting, each one of these components has a standardized symbol. And when you are designing or building these fluid systems, just like an electric system where you have a symbol for voltmeter, you may recall, or an ammeter, each of these systems has a symbol. So we're going to translate this into a schematic. And let's take a look at what that schematic looks like. There it is right there. Manual control of the valve. So we're going to take a look at these different symbols. And what you need to know is not necessarily memorize the symbols, but be able to figure out what type of component the symbol represents. So let's take a look at this. And this might get a little bit dizzy. So here is a schematic. Okay, so the first thing you should know is anything with a circle has a particular meaning, and that particular meaning for a circle is some kind of a rotary device. That is, it turns. There's some kind of turning action happening there, and when we look at an electric motor more closely, you'll learn that electric motors or DC motors have turning components. So it is connected to another turning device, and this little triangle indicates compressor. Triangle indicates some kind of compression happening there. And so you can see that the symbol for the electric motor and the compressor is right here. We got this guy right there. No problem. Now, we're not going to get too fancy. These schematics don't get too fancy with inputs. So there's just a line that represents some kind of input, and that is the air intake filter. That air then has a transmission line, represented by a line, to a compressed storage tank, and that is indicated by a squared off containment box. There's a transmission line that goes to the pressure release valve, and valves are represented by squares. So valves all have some kind of a squareness to them. This square means that there's one position. It can be on or off. You can see over here that we have another valve that has two squares stuck together. This means that there are two possible positions for the valve. Okay, so let's keep drawing our schematic. So you'll remember that so there's our storage tank, and there's a short section of transmission line. There's a short section of transmission line, and this is going to go into this guy right here, this filter. The air comes in, goes through, continues on. Dirt particles can fall down, and we can exit that. So how do we represent that? Well, oh, I forgot the valve. That's why it didn't make sense. So here we are at this valve, and we got two ports on this valve, and we've got two positions, on or off. And you can see that the valve schematic symbol has two boxes. So this is one position. Two boxes represents two positions. And we don't necessarily need to understand the symbols that are happening within, but they just indicate the type of control that is exerted over the fluid. And in particular, we've got this thingy right here indicates, at the start of a cycle or the end of a cycle, what the state of the valve is. Not things that we need to understand, but I want to introduce the concept to you as well. So here we have our first valve. It's got, as you can read from the schematic, it's got two possible positions, and this particular valve has two ports. And you can recognize those two possible positions because on the schematic it has two of these squares. Then we have another transmission line. This arrow represents the direction of flow. Going to move into this diamond-shaped thing, and anything diamond-shaped on a schematic means it's a filter, making sure the fluid is clean to resist abrasion and degradation. And there's different symbols that can happen inside filters as well. I'll just show you a couple of them here. We have a filter symbol with a line at the top. This means that there's lubrication injected into the filter. The dashed line indicates it's got a strainer or a filter as well. Clear open diamond means that there's some conditioning that's happening to the fluid. And there are others as well, which we need not concern ourselves with today. You remember, though, there is a transmission line coming out of the filter into a valve. So let's see what that looks like here. Coming out of the filter into a valve. You recall up here that this has three possible positions. And it's got three ports. And we take a look at this, and it has two different squares. And although we understand that that means there's two positions, this means that one of the positions is not necessary, used, or necessary for the design of the system. So all you need here is a two position. Now we still call it a three-way, and valves have a number of different symbols that are can be located inside. This arrow on an angle to the upper right means it's usually open. We've got other valves or other transmission lines coming off this as well. You may notice we've got the little square thing here coming off here, here, and here. All this means is it's manually controlled. The valve is controlled by a human being or a robot that has to physically turn the valve on or off. It is not controlled by a sensor or some kind of circuit. Okay, so we got that valve described there. This goes off to the muffler. And we have a transmission line that comes out of that valve. There's the airflow symbol. And we know that we're now going to the first compression cylinder. And these are different shapes for different air compression. Usually we have, this is reserved for, it's a compressed gas reservoir. When we have this oval shape, that is for storage cylinders. So, and different storage cylinders can have different symbols inside of them. Remember, this little triangle means that it's pressurized gas. So there's our cylinder right there. Then we have, of course, it's composed of both air and oil. And we have a transmission line. Now we're into the hydraulic part of the system out of the pneumatics. Remember, the oil is here. And we've got this big guy right here. And this is, of course, our actuator. And there are lots of different symbols for actuators, which we won't take a look at. But this symbol right here, it's kind of got a box at the bottom with things coming up. This is the symbol for a cylinder. That is not a storage device. And different numbers of lines or different arrangements means that it's either single acting or double acting. In single acting, all you need to know about this actuator is that fluid goes into and out of the same opening. You don't need to be able to distinguish between double acting or single acting cylinders. And that does the work. So if you were an engineer designing the system, you would use these symbols, much in the same way as you would use electric symbols. And then you would make it real. You would put it all together, test the different components, and see what different components and the design of the different components are necessary to make the job possible. All right, well, there you go. What do you need to know? I keep coming back to that because it's pretty important for you to be able to understand that fluid systems are really advantageous, and they are designed as carefully as electrical circuits are designed. Transmission lines, pipes, and hoses provide the flexibility to transfer fluid to a variety of locations. And a large variety of valves can be used, which allows for greater versatility of control of the forces and pressures within these systems. You got to know that you need some kind of input, usually in the form of electricity, and then some kind of output, which is the word that we give for the mechanical device that is an actuator. It transmits or transforms the fluid pressures and forces into a mechanical fluid or pressure. So you will need to be able to sketch out or understand or follow the story of a fluid system, and look for the homework for an example of that. I'll provide you with a couple of those. Also, I'll look forward to hearing what you have to say next week when we take a look at your quiz, Unit 3, Quiz 1. And there will be some activities involving the video demonstrations and learning as well. Hope that helps. Have a great day. We'll talk to you soon.